Today we are graphing reciprocal functions. A reciprocal function has an equation of the form f of x equals n over b of x, where n is a real number and b of x is a linear expression that cannot equal 0. The parent function of a reciprocal function is f of x equals 1 over x. A vertical asymptote is a vertical line that a graph approaches. A horizontal asymptote is a horizontal line that a graph approaches. Reciprocal functions have vertical asymptotes when the denominator equals 0. So the function f of x equals 1 over x has a vertical asymptote at x equals 0. The type of graph formed by a reciprocal function is called a hyperbola. So this hyperbola here's our parent function of f of x equals 1 over x. The domain is all non-zero real numbers for both the domain and the range. So our y value will never be 0, our x values will never be 0. There are no x or y intercepts. The function is not defined when x equals 0 because 1 divided by 0 is undefined. Where if we have a rational function f of x equals n over b of x plus k, k is a constant, and the horizontal asymptote is y equals k. The vertical asymptote will be the zeros of the denominator. So for our first example, it says determine the excluded value of x. So that's when, keeping in mind, dividing by 0 is undefined. So for this first one in part A, the function is undefined for x equals 0 because we would have 6 divided by 0. For part B, we have a linear expression, set that equal to 0, and solve for x. We would get x equals 7. The function is undefined for x equals 7 because that would make your denominator 0. For part C, set the denominator equal to 0 and solve for x. We would subtract 4 and then divide by 3. So the function is undefined for x equaling -4/3. To graph the expression here, we have g of x equals 1 over 2x minus 5 plus 2. First, we're going to calculate our vertical asymptote by setting the denominator equal to 0 and solving. So we would add 5 to both sides and divide by 2. So our vertical asymptote is at x equals 2.5. So we're going to draw our vertical asymptote here with a dashed line right at x equals 2.5. Our horizontal asymptote is this number here that we're adding to the rational part, which was 2, so y equals 2. So we're going to go ahead and draw our horizontal asymptote. Next, I type this into my graphing calculator. I press y equals, and when I enter that in, it should look like this. So because we have a fraction bar here, the fraction bar acts as a grouping symbol. So I put parentheses around 2x minus 5 before I press plus 2. And then pressing second graph, that takes us to the table, and then I can fill in my table, and then I can plot the points. So starting with -1, 1.86, and then 0, 1.8, 1, and 1.67, 2, 1, and then 3, 3, 4, 2.33, 5, 2.2. So notice it's just getting closer and closer to 2 because that's our horizontal asymptote, but it would never quite get there. So then we have to draw our hyperbola shape. So we basically get the asymptotes divide this into 2 separate curves. Example 3. Ohm's law states that electric circuits operate according to the equation I equals V over R, where I is the electrical current in amperes, V is the electromotive force in volts, and R is the resistance in the circuit in ohms. Analyze the electrical current of a 110-volt curling iron in relation to the resistance of its circuit. So we're going to put 110 in for V. And then to graph that, I would just type it into my graphing calculator and then go to the table and find points, and then we're going to plot the points. Our domain is all real numbers except 0, okay? We can't divide by 0. And our range is all real numbers except 0 as well. It would never cross the x-axis or the y-axis. So we're positive values when r is positive and negative when r is negative. Transformations of reciprocal functions. So what we are subtracting from x in the denominator, that's a horizontal shift, and that's also where our vertical asymptote is. And what we are adding to the rational part is a vertical shift, and also where our horizontal asymptote is. If a is greater than 1, that stretches it vertically, so it gets farther away from our origin. And then if a is a number between 0 and 1, or its absolute value is between 0 and 1, it is vertically compressed. So here a is -4, h is -1, k is -2. So our vertical asymptote, always still just set your denominator equal to 0, and solve for x, we would get x equals -1. So we're going to draw a vertical line at x equals -1, that's our vertical asymptote. And then our horizontal asymptote would be this number here, y equals -2. So then we'll draw our horizontal asymptote at y equals -2. And then typing it into our graphing calculator, here's the buttons that we would press. This is what it should look like on your screen when you type that into y equals. And then pressing second graph, you get this table, and then you want to plot the points from the table, as many points as you could fit. So I start with -6, -1.2, -5, -1, -4, -2/3, -3, 0, -2, 2, and then jumping to the next curve, it would be undefined at -2 or at -1. That's why we have this error. So then 0, -6, 1, -4, 2, -3 1/3, 3, -3, and 4, -2.8. And then we connect our points to make the two curves of our hyperbola. Okay, and then in example 5, we are given the graph and we have to write the equation. So let's take a look at where it appears to have a vertical asymptote. That would be at x equals -4. We see it never crossing that line here. And then our horizontal asymptote appears to be at -2. So x equals -4 is our vertical asymptote, and y equals -2 is our horizontal asymptote. So that's telling us the values of h and k. However, we don't know the value of a. Since we know it goes through the point -3, -3, we can substitute -3 for x and +3 for y. We can substitute -4 for h, -2 for k, and then we'll be able to solve for a. So we have 3 equals a over -3 minus -4 and -2. So -3, this we could think of minusing a negative as adding a positive. So we have -3 plus 4, which is 1. And then I would add 2 to both sides, so we get 5 equals a. And then we can write our equation. G of x equals 5 over x plus 4 minus 2. Thank you for watching.